we're in section 7.10 and negative exponents. All right, so first let's take a note of these properties. Anything raised to the 0 power is going to equal 1. Look at these examples right here. For negative exponents, anything raised to the negative exponent is going to reverse. It's going to turn into this. So 7 to the negative third, since 7 is raised to the negative third power, is equal to 1 over 7 cubed. Same thing with negative 5 negative to the negative second power, you put it to the denominator. So let's look at problem 1. What is the simplified form of each expression? All right, so 9 to the negative second. Now that's raised to the negative power, so therefore it's going to be 1 over 9 squared. When you simplify it, it's 1 over 81. All right, letter B. Negative 3.6 raised to 0 power. Well, since raised to 0 power, this is going to equal 1. All right, so why don't you try Goddard's A and B? All right, problem 2. What is the simplified form of each expression? All right, so let's look at this. We got 5a cubed times b to the negative second. Well, first let's look at what is raised to the negative second, which is b to the negative seconds. Therefore, I'm going to have 5a cubed times 1 over b to the second. So when I simplify, it's going to be 5a cubed over b squared. And that's my answer. All right, letter B. 1 to the x to the negative fifth. Now, let's look at what's raised to the negative, which is x. So therefore, you're going to flip-flop it. Now it's going to turn to x to the fifth. So like here, how we reversed it, you got to reverse it for this one too. All right, so try Goddard's A and B. You see that? A and B. There we go. All right. All right, so problem 3, we want to simplify 3s cubed t to the negative second for when s equals 2 and t equals negative 3. All right, so now this is, you could do this one of two ways. All right, the way I do it is I simplify this symbolically first. That means I do this in variables. So let's look at what is raised to the negative power, the t. So therefore, that's going to be 3s cubed times 1 over t to the second, which means I'm going to have 3s cubed over t squared. So now what I do, after I simplified it symbolically, I'm going to plug in my numbers. S equals 2, so I'm going to have 3 times 2 cubed over negative 3 squared. So when you do that, I have 3 times 8 over 9, which means I get 24 over 9. Or what you can do is you can plug in the numbers. This is the second method. You could, so for 3s cubed times t to the negative second, you can do 3 times 2 cubed times negative 3 to the negative second. Now this looks a little, because there are too many numbers, I might get confused, so that's why I do it this way. Let's finish this way though. So this is raised to the negative power, so then I'm going to have 3 times 2 cubed over negative 3 to the second, which gives me, again, 24 over 9. But do it this way first, because this way is, I believe it simplifies it much more when you plug in your numbers. This looks a little bit confusing. All right, so why don't you try letters A and B? All right. Let's look at problem 4. A population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1,000 times 2 to the h, where h is the number of hours after a scientist measures the population size. Evaluate the expression for h equals 0 and h equals 3. What does each value of the expression represent in the situation? All right, so h is the number of hours. So after 0 hours, there's 1,000 bacteria for the population size. But when you plug in for -3, now remember, you have a negative, oh, you can't see it. All right. Move it a little bit more. All right. So when you plug in -3, you know that this is raised to the -3rd, right? So therefore, you got to do 1,000 over 2 to the 3rd. All right. So then that's 1/8, which equals 125. So there were 125 bacteria 3 hours before the scientists measured the population. Not -3 hours, just 3 hours before it was measured. All right, so why don't you try this? Got it up here.